Hello everyone, once again welcome to Quantitative Methods module. I'm Shiluk Safrov and I will be doing the first lecture on data and data representation, and my colleague Said Mark, he will be delivering the other lectures in upcoming weeks. Okay, let's start. Well, since today we'll be talking about the data and the ways and techniques of how to represent the data to the audience, first we need to understand what data means. The data is basically a collection or a combination of different numbers, events, observations, or types of information, okay? And the data can be of different types. So we have so-called the raw data, the aggregate data, or the primary and the secondary data. We also have, let's say, continuous data or discrete data, and so on and so forth. So basically, they will be going through each of them one by one. Now, talking about this table that you have on the screen, it represents the data set for 8 US colleges and universities, right? So here we have the universities and colleges, we have the so-called variables, and we have the actual data here as well. Now, whenever you work on certain table, like this one, for example, right? Always bear in mind that you have three components of any table. Okay, so the first one, the universities and the columns, they represent as elements of the data of the table, right? Here, for example, we have the variables, all right? And the main part of the table here is basically our data set, our actual data, right? Now, like we said, the data can be of different types. So if we start from the very beginning, first we need to basically define what would be the qualitative or the quantitative data here. So here, as you see, for example, the variable enrollment, the tuition fee, for example, for resident and non-resident students, or the cost of room and board, for example, they are in numbers, as you can see here, right? So what means is this type of information is basically a quantitative data, okay? Now, if you have the variables, if you have the data set that have no numbers but different names. So, for example, here we have the type of the university, like it can be, type of the students who can enroll to the universities. Like code means what both gender representatives can apply for this university, or for example, here if it says women, so only women can apply to this university, or only men can apply to that particular and St. John's University, right? Or we have the control, for example. So we know that the universities and institutions of the college, they can be either public or private. Yes. So basically, if you have this type of variables, then basically we call those variables as what? As qualitative data, right? So we have no numbers, but simply different names, different labels, right? So far, you did understand, hopefully, the differences between the qualitative data and the quantitative data. Now, this particular table basically is a secondary data as well. Why is that? Because if you look at the actual data set here, it's already what? It's already grouped. It is already sorted out or tabulated. We can also say that, right? So basically, when you have these numbers only, if you sort them out according to the universities, according to the college, for example, right, and according to different types of variables, then we call this type of data as what? As secondary data. And at the same time, this one is aggregated data. Why? Because you have already grouped the data by the universities here against what? Against the available variables that you have. Okay, so this table is at the same time aggregate data as secondary data because it's already tabulated or processed or we say analyzed, yes, and it also represents what? Both qualitative and quantitative data. Okay. Uh, Besides the data itself, we also need to understand what scale of measurements we have in order to measure up the data itself, right? So as we said, data can be of different types, right? So you might have some problems while analyzing or processing the data. So here, for example, on the right, you have a picture of 16 differently colored balls of pool, right? So you have the light orange here, dark blue, the fireish orange, and so on and so forth. Now, the problem with this particular data set is basically what? We have no numbers yet. So we don't have the numbers. Let's assume we don't have the numbers yet. Now, what happens is we have 16 different colors. Now, in order to process the data, we actually need numbers because the whole statistics comes from the numbers itself, right? Now, what we're going to do here is we're going to assign certain numbers. For example, the 1 will be assigned to light orange. The number 2 will be assigned to the dark blue. Number 3 is the fireish orange, and so on and so forth. See? Now, once you assign a certain number here, you will have a ready labeled data, or in other words, we call it as what? As nominal data. Always remember, the nominal data is usually initially a qualitative data, but once you label them, once you assign different numbers to different items, right, it becomes what? It becomes nominal data. Okay, now if we move on, now you might have a data set where it's already labeled, but the problem is, again, you can't really process the data as they were numbers, right? So for example, here you have the first, you have the second and the third place of a certain contest, right? And basically this represents a certain order, as you see here. We said that it's already labeled, but at the same time it represents a certain order, because we know that the first place is the best place, the third place is actually like not the best, but the good place, right? Now, if you have this type of um, data set, then we call those data sets as ordinal data, right? Because the thing is, it's already labeled as we said, so it's at the same time a nominal data, but since we have a certain order, like from the first to the third place, then it becomes what? It becomes an ordinal data, right? And at the same time, we have a so-called zero arbitrage for this particular data sets. We will talk about that later. And the third scale of measurements here is called the interval scale of measurements, right? Now, talking about the example first. So you have on the right two thermometers. The one is the Celsius thermometer, the other one is the Fahrenheit thermometer, right? Now, we all know that at 0 degrees, the water freezes, right? Or at 100, like more than 70 basically, right? The water starts boiling, right? Now, the thing is, if you take these numbers, like the 0 degrees or the 100 degrees, right, and it converts according to the Fahrenheit thermometer here, then the 0 becomes what? 32 Fahrenheit degrees, right? So what happens is the water freezes at the same degree, but in Celsius language it is 0 degrees, but in Fahrenheit language it becomes the 32 Fahrenheit degrees, right? And hence our 100 becomes what? Our 100 becomes 212 Fahrenheit degrees. Yes? Now here, as you see, our data is basically already labeled because we have labels here. It follows a certain order because we are going from 0 to 100, yes, or from 32 to 212, yes. And at the same time, we have a certain differences. We have certain differences. And in fact, we do, yes. It's a difference in what? Difference in basically the degrees here, right? And now let me talk about, oops, sorry for that. And now let me talk about the zero arbitrage here. Now, 0 degrees, well, 0 means 0 in mathematics, we know that, but here, in our example, 0 is not actually a 0, because 0 can be a different number according to different, what? According to different language. For example, here, from the Celsius language to the Fahrenheit language, right? And that basically is the meaning behind the zero arbitrage. So not always the 0 means the actual 0. It might be different in different data sets. Okay? And if we move on to our last scale of measurement, which is the ratio, we definitely know now that is already labeled. It follows a certain order. We also have the differences, but unfortunately this time we don't have any zero arbitrage. Okay, that means what? If you have a $0, then that means it is a $0. That means what? You have no money for that. And because we have no zero arbitrage, 0 means nothing. Okay. Now, in sum, what we can actually say is, we usually start from so-called nominal data, right? Whenever you have a qualitative data, you usually start assigning different numbers. Like we said, what? Like what? We start labeling them. And once you label them, you can actually add another feature, which is what? Which is an order. That means what? If your data follows a certain order, then the nominal becomes the ordinal, right? Now, if the ordinal data has, at the same time, if the ordinal data has at the same time a certain difference measurements, right? So then in that case it becomes the interval. And if the interval scale of measurement allows you to have no zero arbitrage, that means what? If the 0 means the actual 0 under the interval scale of measurements, then the interval basically becomes what? Becomes the ratio here at the very end. All right? Now let's move on. Okay, so far we've talked about different scale of measurements as well as the differences between the qualitative and the quantitative data. And initially we talked about what raw and secondary, what raw and aggregate or secondary and primary data means, right? Now in order to better understand those type of data, let's look at this particular example. So here you have a number of refrigerators sold in 1 month by a certain producer, yes? So as you can see, we have 30 different observations. That means what? We have 30 days in 1 month. Right? So here, actually, what we can see is on the first day we have sold 5 refrigerators. On the second day, we've sold none. On the third, we've sold 15 refrigerators, and so on and so forth, right? Okay, now what we need to do is we need to analyze the data somehow, right? And we're going to start our analysis from so-called stem and leaf diagram. Okay, but before that, let me explain you one thing about the differences between the number and the digit. So you have the number and the digit. Okay, so what is that? If you look at the number 5 here, it represents basically the what? It basically represents the 0 plus 5. Yes, that means what? Well, since we can't really say it's the 0, 5, we simply ignore the 0. Yes, 5 actually is a number, and at the same time, this number has only one digit, which is again the 5 itself, right? But if you look at the 15 here, 15 basically can be written as 10 plus 5 here, right? Now at the same time, the 15 number itself has two different digits. One is the 1 and the other is the 5. Yes? So two digits, the 1 and the 5, they make up one number, which is the 15. Alright? So that's the main difference between the number and the digit in mathematics. Now let's move on. Okay, let me clean up the screen very quickly. Okay, now let's move on. Now, talking about the stem and leaf diagram itself. Let's look at the first method first, right? As I said, if you look at the number 5 here, the 5 can be basically written as 0 plus 5, right? Or the 0, 5 here. Well, since we don't write the zeros, we simply put the 5 itself, yes? Now, what we do here is, first we need to assign a certain, we need to assign 0 as of what? As of we have the 0 first, like the 10th digit, right? Well, since we have no 0, we don't write the 0 here, we simply put the 5 instead, yes? 0, 5. Now, if you look at the other number, which is the 0, then 0 is basically the what? In other words, 0 plus 0, yes? And another 0 will be put as a leaf, right? Now, what we're going to do is we're going to quickly skip these numbers. Why? Because first we're talking about the 0, 10 digit, right? We're talking about the zeros only. So what we're going to do is we're going to very quickly eliminate those numbers from our analysis, right? And we're going to move on to the third one, which is the 1, yes? And hence it becomes the 0 plus the 1, 0 plus the 6, 0 plus the 5, and so on and so forth, okay? So basically you got the idea of how to construct the first stem with a number of leaves, right? Now let's move on to the second part of the stem and leaf diagram. So let me quickly erase everything. Now, the second stem basically represents the what? Not the zeros, but the tens this time. Now we have 10 plus the 1, 10 plus the 2, 10 plus the 3, and so on and so forth, right? So this time we're going to look at these numbers. So still 23 is a different number. Okay, 10, 11, 13, 19, 16, 12, and the 14 itself, right? Now what we have here is, if we take the 15, 15 can be written as 10 plus the 5, yes? So what we do is we're going to simply divide them by half once more time, yes? So the 1 basically here represents the what? The 10th unit, and the 5 itself basically represents the other half of the number, right? So 10 plus the 5 is here. If you look at the 18, then that is basically the other number. Then the 10 comes with 0, definitely, right? That's why it's 1 over 0, 1 over 0 for another 10. Then 11 becomes the 1 and 1, and so on and so forth. So basically you got the idea. And since we have only 123, which is the third stem, we simply put it as what? As again 20 plus the 3, or the 23, and like that. Yes. So the 2 basically represents our stem, and the 3 basically represents our leaf, right? Now, if you look at the second method, it basically represents the same analysis, but what we did here is we simply divided the first method by half. Yes. How did we do that? Is so if you look at the first one, the first group basically represents the numbers up to 5. Yes. So as you see here, we have the zeros, the 1s, the 2s, the 3s, and the 4s, but not the 5, not the 6, or the 7, 8, 9s, right? So what we did here is we simply took the first stem and we divided into 2 halves. So basically the numbers up to 4 and the numbers from 5. So what we're going to do is from 5, yes, and up to 9. All right. So in that manner, you're going to simply apply this rule to the other stem as well, okay, and to the third stem. Well, basically, since we have only one number, we'll have only one stem for both methods. Okay, there's another method of analyzing the data sets here. So we have the same data set so far. Now what we're going to do is we're going to construct a certain so-called frequency table, all right? Now before that, we need to basically understand first the range of the data set. So as a minimum number, you have the 0, and as a maximum number, you have the 23. So basically, the range itself, I mean, the difference between the minimum and the maximum number is basically 23. Now what we do is we're going to simply take the 23 here, which, as I said, represents the 23 minus the 0, like difference between the minimum and maximum numbers, right? And then you're going to simply divide it by a certain number. Now what number? By a desired number of groups that you want to have. For example, here I decided to have 5 different groups, right? So hence what I'm going to do is I'm going to simply divide it by 5. So if I divide it by 5, I'm going to get somewhere around 4.6, which is around 5 again, right? So what happens is, since I've got 5 here, I'm going to divide the data set into groups with the range of 5, okay? So we've got the numbers from 0 to 4, then from 5 to 9, then from 10 to 14, 15 to 19, and from 20 to 24, okay? Now once I have those groups, I'm going to start counting how many observations I have. For example, here, from 0 to 4, apparently I have 10 observations, or from 5 to 9, I have 9, 6, 4, or 1 observation only, yes? So once I have this count, which is basically the tally, I simply rename it as frequency. Frequency is basically how frequently the same observation appears within one group, okay? So once we have the frequency here, what we do next is, so let me clean up the screen one more time. So once we have the frequency here, we need to construct a so-called cumulative frequency. Now what cumulative frequency represents is, here we simply keep adding our groups. Yes, for example, in the first group we have 10, and we don't have the group 0, that's why we're going to start from the 10. Now in the second group we have the 9. Now what happens is we're going to simply add the 9 here and put it as 19 for the second group as a cumulative frequency, yes. Plus the 6, it becomes the 25, plus the 4, that becomes the 29, and plus the 1, of course, it becomes what? It becomes the 30. And why 30? Because we have initially, if you remember, 30 different days and 30 different observations, right? And as a last step, we also need to construct a so-called relative frequency. Now what happens here is, we're going to assign the 30 as 100%. So basically the main question here is what percentage of this particular group, for example, represents the data type, right? So here, for example, if you have the 10 frequencies, then if you divided the 10 by 30, so 10 over 30 here, then basically you will end up with what? Something like this, right? Or in other words, roughly saying it's around 33%, right? Or if you divide the 9 by 30, again, you would end up with 30%, or the 20%, or the 13, or the just the 3%. Okay. Now always remember, when we work with percentage, we can actually represent our results in 2 different ways. For example, if you take the 0.33 here, it is actually the same as 33%, or if you want, you can write it as 1/3, or basically that's the 3 over 9. Yes, so it's up to you how you represent the data, but as long as what? As long as it is clearly represented. Okay, so if I say 33%, basically then I'm referring to either this number or to that number usually. Okay, always remember the 100% itself here is the 1. All right, good. So once we have constructed this particular table with so-called the frequencies, the cumulative frequency and the relative frequency, now we need to illustrate the data, I mean our results, graphically somehow, yes? Now, the top right graph basically represents the what? The frequency column, yes? You have the number of days, you have the number of refrigerators sold in a particular month, right? And you have different groups like we initially constructed, yes? And you have the actual data. So in the first case, you have the 10, so that's why the first bar is up to 10, the other bar is up to 9, then 6, then the 4, then the 1 itself, right? So basically this particular graph represents the so-called histogram. Now the same histogram can be constructed using the what? Using our cumulative frequency, okay? So again, the x and y axis, they represent the number of refrigerators sold and the number of days we have in a particular month, right? And then we're going to simply construct a line graph based on the cumulative frequency numbers. Okay, so in that case, what happens is your line graph must start always from 0 and end up to our total number. All right, so this is the other histogram. All right, now let's move on. This time we're going to look at a different type of data. So here we have the GM automobiles sold only in 1 day. So previously we talked about 30 days, right? But here we're going to talk about only 1 day and with 5 different observations. So where we have, in which we have the Nexia, the Matisse, the Cobalt, the Malibus, and the Sparky. Okay. Again, what we're going to do is we're going to start counting first, right? According to our different data items. So since we have different type of data here, like not numbers, but qualitative data, like names. What we're going to do is we're going to simply count them first. For example, we have 14 Matisse, or 8 Cobalt, 9 Spark, 11 Nexias, and 8 Malibus sold in 1 day only. So that means what? 50 people, they simply came to the store and they bought this particular car models, right? And then, again, once we're done with the frequency, we're going to move on quickly with the calculations of relative frequency. So this 50 basically represents our 100% or the one itself, right? And then we're going to simply do what? Again, divide them all individually by the total number. And hence you're going to end up with 0.28, or which is, again, like I said, the same as 28% or the 16%, and so on and so forth, right? So in total, it must be the same as 100 or just the 1. Oops, sorry for that. Okay, now once you have this table, now what we need to do is we need to somehow illustrate our results graphically, yes? But this time, unfortunately, we can't construct the histogram. Why? Because we have no groups, but we have 5 different elements. Okay, so instead of that, what we can do is we can actually construct either the bar chart, which is the left chart, or the pie chart, which is the right chart, right? Again, the car models, they will appear on the x-axis, and you have the frequency or the number of cars sold on the y-axis, right? And you have these bars. Of course, the Matisse, well, since we have 14 here, the Matisse will represent the 14 height of bar, then the Cobalt will represent the 8, the 9, the 11, and the 8 itself, okay? But again, if you want, you can actually use the relative frequency here and then construct this pie chart, this particular pie chart, okay? Always remember, the only limitation or the main limitation of the pie chart is what? When you add up these numbers, it will be definitely 100%. We know that. But the problem is we don't actually know what number represents the 100%. So is it 50, like we have previously? Or is it the 100 itself? Or is it like the 1,000, right? So that's basically is the main limitation of the pie chart. So you have to consider this limitation whenever you want to construct a certain pie chart on your given data, okay? Okay, now we've gone through 2 different data sets. The left one, if you remember, it was the number of refrigerators sold in 1 month, and the right one, that's basically is the car model sold only in 1 day. Now, if you look at these 2 different data sets, they are actually different, yes. In the first data set, we have a time series data. We call it as a time series. Why? Because we have only one variable, and that variable is basically our refrigerators, yes? And this particular variable is being observed over a certain time period, which is basically 1 month or the 30 days. Yes? But if you look at the other data set, the right one, you have no. But if you look at this particular one, you have 5 different variables, where you have 5 different car models, right? And the thing is, these models, they are not being observed over 30 days, but over only 1 day. Yes? So we call this type of data set as what? As cross-sectional data set. Okay? So one variable being observed over a certain time period, that becomes a time series data, or a number of variables being observed only at point in time, that means what? At one single day, then that becomes what? A cross-sectional data. That's the sum. That's the main differences between the 2 data sets. So far, now we know, we've understood differences between the time series data and the cross-sectional data. Yes, and at the same time, now you know how the raw or the aggregate data looks like, or the primary or the secondary data looks like. Yes. Now, what we're going to do is we're going to look at other techniques or ways of representing data to the audience, right? So, as an example here, I've got the profit figures of three imaginary textile companies, right? So, they are the Us Cotton, the Cotton RUZ, or the Cotton, just the COTUZ companies, right? Over the certain time period from 1998 to 2001, yes? And again, the data set is given in million Uzbek sonas, all right? Now, basically, the best way to represent this particular table is what is simply to construct a certain line graph. Yes. So here you're going to assign three different colors, or if you want, you can assign three different lines, like dashed dotted lines, right? And then we're going to simply need to find the sorry for that, the dots, the actual data sets here, right? So for example, if you look at the Uzcotton company, in 1998 we had 250 million profit figure, so we're going to assign that number. Then during the following years we have the 300 that went down to 50, followed by zero profit figure by the end of 2001. Yes, and then what we do is we're going to simply align these four dots. Yes, so you can basically do the same thing for the other two companies here. Or we have a so-called scatter graph. Here as an example, I took the grades of 30 students from two different modules. The one module is the science, the other module is basically the math. So as you see here, we have the first student, for example, receiving the 52 mark from science and 46 mark from math. The second student got 56 and 48. The third student got 56 and 48 again. The fourth one 58 and 50, and so on and so forth, right, respectively. Now what you need to do in order to construct the scatter graph is we're going to again quickly assign these two modules as x and y axis, so it doesn't really matter whether you have the math on the x-axis or the y-axis. So here I have the math on the y and science on the x-axis, right? Now what I'm going to do is I'm going to simply try to find these points in our graph. So okay, so once you have this point here, so let me erase it. Actually, I don't need that. You could actually see that we have a certain positive trend line. Yes. So what would be the summary that we can derive from this particular scatter graph? So as long as you study better the science module, there's a high chance then that you will get a higher mark as well, right? Or the other way around, if you have the math module, for example, on the x-axis and the science on the y-axis, the other way around, yes, then you could actually say as well, like what? The higher the better you study in math module, then the better you study in science module, or the higher the mark you get from math, the higher the mark you will get from science. Okay. Now we're done with the first lecture. Thanks very much for watching this video. Like we said previously, please, after watching this video lectures, go through the lecture slides and the lecture notes multiple times, right? And do some home reading before coming to the seminar classes. Thank you. Bye-bye.